So for our learning target for today, it says I can multiply and divide integers, that's positive and negative values, using my integer rules. I can convert fractions to decimals through division as well. So we're going to be covering a couple different components for today. Covering our rules and then using them in our operations, so word problems, some contextual problems. And then we're going to be doing some practice of converting. Okay, so the first thing that I want to go over real quickly with you guys is the multiplication and division for your integer rules. So I know it just says multiplying, but this is also for division. This is how we multiply and divide. So right below it, put and divide. So multiplying and dividing with integers. Multiplying and dividing integer rules. So there's two different things that you can utilize when you are doing your multiplication and division. Okay, so you can just memorize the rule that if you've got a positive and you are multiplying or dividing, I'm going to put a little division sign there too, multiplying or dividing by another positive, we know it's a positive. If it's a negative and we are dividing or multiplying or dividing by another negative, it is a positive. If you take a positive and you multiply or divide by a negative, it comes out to a negative. And if you take a negative and you multiply or you divide by a positive, it comes out to a negative. Sometimes it's easier to see these if you just go ahead and highlight your positives with the green. And if you highlight your negatives with the pink. Your mouths don't require you to get things out, it's just your hands. So this is one thing that you could utilize. You can memorize this little board here, or you can utilize a different method, which is what we call the triangle, the multiplication division triangle. So this again is only true for multiplication and division. So write this down. This is to multiply and divide integers. This is only true if you're multiplying and dividing with integers. That if you've got a positive triangle, so we've got a little positive part at the top of our triangle. Down here at the bottom, we've got negative and negative. And how this works is that when you know what you're multiplying, you cover it. Or if you know what you're dividing, you cover it. And whatever's still showing is what the answer is. Here's what I mean. If I know I'm multiplying a negative times a negative, I'm going to cover a negative and a negative, and what's the only thing left showing in my triangle?
Positive.
A positive. So I know a negative times a negative is going to give me a positive answer, or a negative divided by a negative gives me a positive answer. If I know I'm doing a positive divided by a negative, what is my answer? Negative. So what you cover is the problem. What still shows is your solution, the sign for your solution. Now, obviously, we don't have to have it for positive and positive. You guys know positive and positive is positive. You've been doing that since 3rd grade. You have done multiplication and division since 3rd grade with only positives. So you don't need the triangle to show you a positive and a positive. Okay? So the triangle is really helpful for you guys. And it's something so quick and easy that when you're working on an assignment or you've got scrap paper, you just draw the triangle real quick at the top of your paper and you can just cover with your fingers. It's a very easy tool. Okay, so without the use of calculators, no calculator right now, I want you guys to go ahead and do these 6 problems. Utilize your triangle. Go, okay, I've got a negative and a positive, so I know my answer is a negative. Okay, I've got a negative and a negative, I know my answer is a positive. And then work them out. Okay, let's go ahead and go over it real quickly. So for here, we have a negative that we are multiplying by a positive. So that means that my answer is going to be a negative. So I should have a negative 6 as my answer. For problem 2, we have a negative that we are multiplying by another negative. So that means my answer should be what? Positive. So we get positive 20. Okay. For number 3, we have a negative and we are multiplying by a negative. That means we should have a positive. We should get positive 120. Okay, for number 4, we have a negative and we are dividing it by a negative. That means it's going to be a positive. And negative 20 divided by negative 5 is positive 4. Strong and wrong, dude. Okay, here it's a fraction, but fractions are also division signs. Look at our division symbol. It looks kind of like a fraction where the 2 dots represent numerator and denominator. Fractions are a division problem. So you're taking a positive and you are dividing it by a negative. That means that the answer is going to be negative. So 24 divided by negative 6 is a negative 4. And then we have a negative and we are dividing it by a positive. That means our answer is going to be negative and we'll get a negative 8. Okay? Let's go ahead and flip it on over to the back. We've got some word problems, some contextual examples, things that are related to real world situations, and we need to identify the operation before we can actually start solving them out. So these are some key operational terms that we need to make sure that we are utilizing. So one thing that I want to make sure you guys understand is the different vocabulary. So for multiplication, we have obvious words like multiply and times. Product means that it's the answer to a multiplication problem. Area is a contextual example. You know, when you're solving for area of some situation, you are multiplying, you know, a length and a width or some sort. You have the word by, that's also a multiplication. And notice that we also have these different symbols, right? We've got the X symbol, we have the dot, we can put things in parentheses. We're not going to be using the X symbol as much as you would have in the past, just because we're going to start getting into algebraic statements as well. Then we have words that represent not just multiplication, but what you're multiplying by. So the word double and twice means you're going to multiply by 2. The word triple means you're going to multiply by 3. Okay, then we've got our division words. We have words like quotient, which is an answer to a division problem. Splitting things into equal parts, dividing it into something, or how much does it go into it. Setting up a ratio, which is a fraction, right? Fractions are ratios, those are division. And then, of course, if I say I'm taking half of something, that's another way of saying I'm dividing by 2. If I take a third of something, I'm dividing by 3. A fourth of something, I'm dividing by 4. Okay, and your symbols, we've got the traditional division symbol. We also have little slashes, or you can make a fraction where this is your numerator and this is your denominator. I'll write that in a darker value. This would be where your numerator goes. This is where your denominator would go, on the top and the bottom of the fraction. Okay? Now something else that's really important for you to remember, and I want you to put this up at the top of your paper, the very top. When we're talking about positive and negative values, something that you need to make sure you keep in mind, people and time are always positive. People and time are always positive values. So if they're giving you a value of time, like, oh, it's this many days, it's this many weeks, it's this many minutes, it's this many hours, this many years, that's a positive representation. If you're telling how many people are in your class, how many people are at work, how many people are on your team, how many people are in your home, that's a positive representation. Okay? So please keep that in mind. Now, let's take a look at a couple of these keyword or these contextual word problems. Elena overdraws $25 on her account every day for 4 days. So how much total is in her account? Is her account overdrawn by? Want to know how much did she overdraw by? So in this situation, we've got the term overdraws. Overdraws is a negative value. When you overdraw an account, that is a negative. So we're dealing with a negative 25. Now she's going to do this every single day for a period of 4 days. Again, days is positive. So we're dealing with a 4. That's positive. So now we got to figure out, are we multiplying or are we dividing? So she's going to do this today, tomorrow, the next day, and the day after that for 4 days. Are we multiplying or dividing here? Multiplying. The fact that she's doing this every day for the next 4 days, she is multiplying here. So negative 25 times 4 is going to come out to a negative 100. All right, Alex's team lost a total of 54 yards in the first quarter. All 9 players lost the same amount. So how much did each player lose? So here, again, let's talk about the numbers. 54, positive or negative? Negative, right? Because it's lost. They lost a total of 54 yards. All 9 players lost the same amount. So how many players are there? 9. And they're people, right? People are positive. Even though they lost, they themselves are positive. What we wanted to know is how much did each of them lose? So it's the fact that they lost the same amount. Same amount is another way of saying equal parts. They each lost an equal amount of yards. So we're going to divide. Negative 54 divided by 9 players, and that's going to come out to negative 6 yards per player. Oops, yards per player. Each player is going to lose a total of 6 yards. All right, the temperature falls 3 degrees each hour for 8 hours. What is the total change in temperature over the 8-hour period? Okay, so the temperature falls, positive or negative? Negative. It falls 3 degrees. It's going to do this each hour for 8 hours. Positive or negative? Positive. We're talking about hours. That's positive. Okay, now what are we going to do? Are we going to multiply or divide in this situation? Gal? Multiply. You're going to multiply. They're dropping 3 degrees this hour, 3 degrees the next hour, and the next hour, and the next hour, and it keeps going 3 degrees every single hour for 8 hours. That is going to be a multiplication problem. So we are multiplying negative 3 times 8, and that means after 8 hours, it's dropped a total of 24. 24 degrees dropped. Try number 4 on your own. All right, so a submarine dives 20 meters. Again, the word dives would represent negative. and it's going to do this for 15 minutes. 15 minutes is a positive value. So what is a total change after 15 minutes? It's going to keep doing this each time for each minute. That means you are going to be multiplying. So you're taking negative 20 and you're multiplying it by 15, and that's going to come out to a negative 300 meters that you have dived down. Negative 300 meters. Okay, let's go on to the next page. Turn it on over. Or turn to the next page, I mean. Max lost 24 pounds in 8 weeks. He lost 24 pounds in 8 weeks. We want to know what is his average drop per week. So he lost 24 pounds over an 8-week period. So how much on average was it each of the weeks? What operation do you think we're going to do then, guys? Angel? Division. Right? We have a total amount he lost. We have a total amount of time that it took him to lose it. Now we want to break it into equal parts per one measurement of time. So it is going to be a division problem. It is going to be a division problem. So we've got 24 pounds that he lost. That's a negative. We've got it over a period of 8 weeks. 8 weeks is a positive. So how much did he lose each week? Josiah? Negative 3. He lost 3 pounds each week. Okay? Keither borrowed $4 a day until he had borrowed a total of $88. So how many days did he borrow the money? He borrowed $4 every day until he had finally borrowed $88 in total. So how much did he borrow each day? What operation are we doing there? Are we multiplying or dividing? Dividing. Okay, and then he borrowed is a negative, right? He borrowed $4 until he had a total borrowed amount of $88. So that means we're going to divide. We're going to divide the total, negative 88. We're going to divide it by how much he borrowed each day, negative 4 each day. And then our answer, is it positive or negative? Positive, right? Because we're trying to figure out how many days did he borrow. He borrowed for a period of 22 days. That's a positive value. Okay, we're going to stop here for a second. Okay, what we're going to do now is we're going to take a look at different situations for rational, converting your fractions into rational decimals. A rational decimal is a decimal that terminates. What does terminate mean? If I say it terminates.
Kill.
Huh? Kills? I mean, you think a Terminator, but yeah. It's what?
Get rid of?
Not get rid of, but not to eliminate. Not cancels. It's going to stop. When it terminates, it stops. It has an ending position. It seems a little odd, I know. You guys are thinking Terminator movie, but the actual term of terminate means to stop it. When I terminate a program, I'm stopping the program from running. Okay? So terminate means to stop. Repeat means it goes on, and it's the same value or set of values over and over and over again. So when we're talking about rational numbers, I want you to write this at the bottom. Rational numbers can be written as decimals that terminate, which means to stop. So I'm going to put stops. Or repeats. So when we're talking about rational values, we're talking about numbers that, you got your whole numbers. Whole numbers are also decimals. Okay, 6 can be written as 6.0. That's a terminating decimal. Okay, negative numbers, -7 can be written as -7.0. Those are considered rational numbers. And then if they happen to be a fraction, you can convert it to a decimal. That if it converts, it would be a terminating decimal, like 0.25 or 3.7. Or it repeats, like maybe it's 3.7 repeated, so it's 0.777777, it keeps going on forever. Okay, so what we're going to be doing here is we're going to identify these rational examples, but we're also going to identify what one is not like the other and what we think might be the reason for it. So when we're looking at this very first problem, we've got negative, and as a fraction, we've got negative and then 3/5. So when we write this as a division problem, we're going to write our fraction bar, or not fraction bar, sorry, our negative sign, and then in parentheses, we're going to write 3 divided by 5. So if you were to use your calculator, you would type your negative sign, which is at the very bottom of your calculator in white. You would then have your parentheses, and you would type 3 divided by 5 and close parentheses. When you hit enter, it's going to come out to -0.6. So this is -0.6. Okay, and then we can do the same thing here. Okay, now we've got -3 on top and then 5 on the bottom. That means we're going to do -3. Make sure you're focusing, Judy. Divided by 5. Cameron, make sure you're focusing. -3 divided by 5 means it's going to come out to a -0.6. For our third fraction, we've got 3 on the top and -5 on the bottom. So I'm going to do 3 divided by -5. 3 divided by -5 also comes out to -0.6. And then for our last example, we've got -3 over -5. -3 over -5 means we're going to do -3 divided by -5, and that comes out to a positive 0.6. So which one is not like the others? The last one. Okay, all the rest of these came out to negative answers. Right, we got a -0.6. Here we also have a -0.6. Over here we've got a -0.6. The last one is the only one that came out to a positive answer. So here's my question to you. What's different about this problem that's not the same with these three? Ashir? It has 2 negatives. If we look at the ones that have negative answers, they each only had 1 negative sign in the question, right? They had a negative sign in the front, or they have a negative sign just on the top, or a negative sign just on the bottom. Whereas for the last one, we had a negative sign on the top and on the bottom. That double negative creates a positive. So if you're saying that your answer is supposed to be negative, and you write it as a fraction, and you write both of them as negative, that's not going to be a negative fraction. That's actually going to be a positive. Okay, now notice I changed the denominator for the second example to a 6. Go ahead and do that. Reflect that change, please. And then I want you to do the same thing that we did here. I want you to do it here. Let's take a look at what it looks like for problem, for the first one that says 2 over -6. That means you should be writing that it's 2 divided by -6. When you do that, you're going to get a -0 and it comes out to 3, 3, 3, 3, 3. It keeps going, right? That means it repeats. To show that it repeats, you don't have to write all those 3s. You can write a single 3 and put what we call bar notation over top. That little line over top of that number shows you that that value is going to repeat constantly. Okay? For the second one, negative 2 over negative 6, we would do negative 2 divided by negative 6. That would come out to 0.3 repeated, so bar notation over top. Negative and then 2 over 6 means you have a negative sign, parentheses 2 divided by 6, and that comes out to negative 0.3, bar notation on the 3, because it repeats. And then negative 2 over 6 means you do negative 2 divided by 6, and you again get negative 0.3, and the bar notation 3 is going to repeat. Okay, so again, the ones that all come out to being the same are right here, the ones that have a single negative sign inside of the problem. They all came out to a negative 0.3, and the 3 repeats. The only one that did not come out to a negative is the one that had the double negatives. That comes out to a positive because of those double negatives here. Okay? Did you have a question? No? Okay. All right, any questions about this? Okay, your assignment today is Delta Math. It has been created, so all you have to do is go to Google Classroom. You're going to go to Google Classroom. Let me show you what we're going to do.